Okay, so I'd like to go over homework 5 since I am not in class today to go over it. This video will just go over the questions. If you have any additional questions about these 5 questions from homework 5, I'm happy to go over them, when I'm in class tomorrow. But I just wanted to at least give you an opportunity to see each question worked out so you could check your work. Question number 1 was, again, all of these questions were from lesson 5, which was factoring perfect cubes. I do think some of us got a bit thrown off because once you got down to questions 3, 4, and 5, they were not cube questions. It was just 1 and 2 that were factoring by cubes. 3, 4, and 5 were other methods. I'll talk about them when we get to them. So question number 1. Initially, these are not the sum of 2 cubes because there's a GCF. Always look for a GCF first. There is a GCF factor of 3. When I factor that out, I should get x cubed plus 64. So now x cubed is a perfect cube because x to the third power is x cubed, and 64 is a perfect cube because 4 to the third power is 64. So when we're looking at that formula with our a's and b's, x is really representing my term of a and 4 is representing my term of b. So when we break down any kind of sum of cubes, it factors into a plus b times a squared minus ab plus b squared. And how you remember those signs is our SOAP. S stands for same. These should be the same, both plus. O stands for opposite. And then AP stands for always positive for that last term. So here I would bring down my GCF of 3. I would have a binomial factor of x plus 4, x squared, and 4 squared would start and end my trinomial. If you want to write that as 16 right away, you can. And then 4 times x with a negative in front would be the middle term. You would most likely see this written with the 16, so I'm just going to simplify that. Okay, question number 2 also has a GCF. In this case, we have a GCF of 5x to the third. Once I factor that out, I get 1 minus 64x to the third. This is the difference of cubes. 1 to the third power is 1, and 4x to the third power is 64x to the third. So 1 is my A and 4x is my B. So let's bring down my 5x cubed. 1 minus 4x would be my binomial. 1 squared and 4x squared would be my first and last terms of my trinomial. And 1 times 4x would be the middle term. Now everything here is positive since my minus sign is already in my binomial, or remember, same, SOAP, opposite, always positive. I'm just going to rewrite this one more time to clean up my trinomial. So 1 squared is just 1 plus, I'm just going to write this as 4x. You don't need the 1 times 4x. If you kept that, it would be fine. And then 4x squared would be 16x squared. Don't forget to square the 4 and the x. You do not have to rewrite this trinomial in standard form. That is completely correct to leave it this way. But if you did rewrite it in standard form and put the 16x squared first and the 1 last in the trinomial, that would be completely fine as well. Okay, so those were our 2 cubic factoring questions. When we get to number 3, this is a trinomial tram factoring question. A does equal 1. So I'm just going to ask myself what multiplies to 8, what adds to negative 9. So what multiplies to 8 and adds to negative 9 would be negative 8 and negative 1. And since I'm multiplying to m to the 4th, not m to the 2nd, I have m squared times m squared. Now, m squared minus 8 is not dots because 8 is not a perfect square, but m squared minus 1 is, since 1 and m squared are both perfect squares. So that breaks down into m plus 1 and m minus 1. Question number 4 is also a trinomial, but unlike number 3, a does not equal 1. and 17 and 21 are not divisible by 2, which means there's no GCF. So I have to take my eyeglass method, or tricky tram, which is really a factor by grouping method, with a little bit of extra work initially because we need to make this into a 4-term polynomial. So 2 times 21 gives me 42, and I'm looking for what multiplies to 42 and adds to 17. Again, you can always go to your y equals, type in 42 divided by x. If you want to go into your y2 even, you can type in x plus y1. The y1 is in alpha trace in the calculator. And then go to your table. If you look at your y2 column, you're looking for 17. You're looking for that addition value, and next to the 17 you will see a 14 and a 3, because 14 times 3 is 42 and 14 plus 3 is 17. So I'm going to now rewrite that middle term. Instead of 17b, I'm going to rewrite it as 14b and 3b. And now I'm going to split it down the middle. I'm going to factor out a GCF of 2b and factor out a GCF of 3. So my 2b and 3 are going to group together and multiply that common binomial factor of b plus 7. And the last question here, again, I can see this is a binomial, but initially I do notice there's a GCF. There's a GCF of 3x. So once you factor that out, you would get 4x to the 4th minus 9. And this is the difference of perfect squares. 2x squared plus 3 and 2x squared minus 3. Okay, I hope going over these 5 questions in this video was helpful. And again, if you have any additional questions or anything that you would like to go over further from these questions, please ask me in our next class together. Thank you.